Welcome to Session 21, Multi-Step Modeling and Answer Choice Strategy. This lesson develops mathematical reasoning that stays reliable when a problem looks unfamiliar. You will learn to translate unfamiliar situations, to choose a useful representation, and to use answer choices as evidence. These are connected habits, not isolated tricks. Keep a pencil ready. We will build a mental model, use a repeatable method, solve a demanding example, diagnose an error, and finish with an independent checkpoint. Start with this principle. Hard problems combine familiar structures behind unfamiliar wording. Use this visual structure. Known is greater than check it, is greater than model, is greater than solve, is greater than independent check. Read every symbol and label before calculating. The first goal is to translate unfamiliar situations. Connected to the second goal, choose a useful representation. Correct calculation begins with correct interpretation. When the surface details change, search for the same relationship underneath. Transfer means choosing the structure from evidence rather than waiting for a familiar-looking example. Step 1. List known quantities with units. State the target and preserve its units or conditions. Step 2. Circle the exact target. Use a separate line so signs, factors, and labels remain visible. Step 3. Build a diagram, table, equation, or choice testament. Keep the reasoning efficient, but never skip an operation that could hide an error. Step 4. Verify through a different representation. Verification is part of the solution because it tests the answer from another direction. Signal 1 is units cancel cleanly. Respond by remembering. Trust the conversion path. Name the response before calculating. Signal 2 is choices are concrete. In that case, consider backsolving. The form tells you which tool fits. Signal 3 is an option is an intermediate value. Remember, reread the final target. This separates plausible work from valid reasoning. If you cannot name the signal, pause and classify. A deliberate choice of method is usually faster than repairing a rushed setup. Here is the challenge. Why solve one labeled step at a time? Restate what is requested before touching the choices. The first move is list known quantities with units. Apply it directly to the quantities and conditions in this problem. Now use the core reasoning. Labels show what each intermediate value represents. Keep each equality, comparison, or unit conversion visible. Pause for a midpoint audit. Check copied values, signs, units, restrictions, and whether the current result is the requested quantity or only an intermediate value. Continue by applying this control. Build a diagram, table, equation, or choice testament. The explanation supports one option without relying on its position. The mathematical conclusion is it preserves meaning and makes errors traceable. State it with any required units, interval notation, or restrictions. The final answer is it preserves meaning and makes errors traceable. Compare it with the exact target and reject any choice that represents a common intermediate step. Verify from another direction. Solve once symbolically and once by testing a choice or estimate. The check should use evidence independent of the original calculation whenever possible. Try this checkpoint without copying the example. Why can changing representations help after a stall? Decide which mathematical fact controls the answer. Pause and write one line of reasoning before committing. A visible decision is easier to inspect, explain, and correct than an unsupported guess. F-focused hint. Equivalent representations can make different relationships visible. Use the hint to repair the setup, then finish the reasoning yourself. The accepted answer is a table, graph, or choice test may expose structure hidden in the first method. Explain why it works, and name the earliest line that would reveal a likely error. The central message is to translate unfamiliar situations. Combine that with the discipline to choose a useful representation. Finish by remembering to use answer choices as evidence. A result becomes dependable only when the method and verification are both clear. Reflection. Which intermediate value is tempting but does not answer the final question? Name the exact point where an incorrect path would first become visible. Practice one fresh problem for 8 to 12 focused minutes. Keep the work readable, verify independently, and carry the routine into the next session. Before moving on, close the notes and explain the method aloud from memory. Then invent one small variation, predict how the answer should change, and verify that prediction with a complete calculation.